Okay. Yeah. Well, thank you, Rebecca. I appreciate it. And thank you, everyone, for taking time out of your day to find out a little bit about Upstream Technologies. We are a small company out of Minnesota, started back in 2012. I have been with Upstream since 2015. So coming up on, let's see, 9 years, I guess. So been a while, but we started with one product, and now we have three different products that we work with. All of them are water related. As you can see by this picture, this is northern Minnesota. I don't know if anyone's ever been up here, but this is obviously in the summer, in the winter, and that's coming very soon. This will all be frozen and full of snow and a little bit different, but we really are surrounded by water. And so our company's goal is cleaner water for the next generation. And that has been kind of our general goal for a long time. And back in 2020, we kind of got a little bit more serious about what our true goal was. And we put together a real specific goal. And so in 2020, we said, okay, over the next 5 years, we want to prevent 100 million pounds of sediment, plastic, and garbage from entering the rivers, lakes, and oceans by 2025. And shortly after we made that goal, COVID hit. And, you know, the world changed a little bit, but we are still trying to work on that goal, even though it's been a little bit of a change in the way that we do business. Like this presentation right now, normally I'd be there in person, but things have changed. Right now we're at 32 plus million pounds, and so we're still trying to get to that 100 million pounds in the next 2 years. And so we got a ways to go, but that's what we're doing when we wake up in the morning. That's what we think about. So we're doing that through three different products. I'll go through these today, so you guys are aware of them and are familiar with kind of their, I guess, history, where they came from, what they're all about. And my hope is, number one, that you have an understanding of who we are as a company, put a face with a name, so to speak. And if you guys run into any situations or projects or questions, would love to be a resource for you and someone that you could reach out to, and we could hopefully work on some projects down the road if they come up. So I'll start out with talking about the product on the left, which is the MPD infiltrometer. This is an automated replacement of the manual double ring test. If any of you guys have done double ring tests, you know that it's very cumbersome and time consuming. This is a game changer, we believe, for people that have to figure out how quickly that ground is infiltrating. So I'll go through that first, and then I'll focus on the Saffle Baffle on the right, which is our flagship product. This was developed by the University of Minnesota back in 2011, and we took over as the manufacturing and marketing of that product in 2012 and started Upstream Technologies. Our most recent addition is the product on the far right, and that is called the Skunk, and that goes over the outlet pipe to capture all the floatable debris and garbage. So I'll go through some history about where we came from and how this all came to be. But both the MPD infiltrometer and the SAFL baffle had their origins from the University of Minnesota. And so that's where they came from. The skunk was one that we came up with kind of through the process of running into some issues with other products. And so we created that one, and that's our most recent product. So I'll jump in. Please feel free to just bring up questions as they come. And if there's anything I'm missing or don't know, I can find that out for you and get back to you. But I'll start with the infiltration. Currently, there's lots of ways to do this, but most of them are pretty cumbersome and time consuming. If you guys, is this something that you guys do internally? Is it anything that you do at all? Is it something that you hire out at geotech? Is there different groups that maybe you do this or don't do this on the presentation today? Oh, okay. 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 Well, I'll go through it, and so you guys are aware of it. It's something that if you do any kind of work with this, it's a definite time saver, money saver, water resource saving technology. And if nothing else, it'll be good for you to be aware of it just in case something ever comes up down the road. So I'll go through it pretty quickly, but this is designed to help sizing rain gardens, retention ponds, infiltration ponds, sizing them appropriately. So when that ground is fully saturated, how quickly is that going to infiltrate? Make sure they're the right size. But then after that, make sure they're maintained, make sure they're working properly. And so these are the tests that are done to figure that out. And what it's calculating, if you look at this chart, there's products out there that just measure the infiltration rate. But what we're really getting to is once that soil is 100% saturated, or that red line, what's the infiltration rate at that point? Most of these products, you have to saturate the ground, and that's why it takes so long. This product, we predict the saturation rate and able to calculate the KSAT, whether the ground is fully wet or dry. So that's what we're getting to, is that red line. There is products out there, like I mentioned, that just measure the infiltration rate. This is a product called the Turf Tech. They use this in golf courses and stuff a lot, just to see if the ground is infiltrating, if they need to irrigate, if it's wet, if it's dry. But again, going back, that's just somewhere along that falling curve. Eventually it gets where that ground is fully saturated. That's where we want to be. And so up until now, really cumbersome ways that this was done was drill a borehole or a perk test, fill that hole over and over again until it's fully saturated, and then measure the drop. And how long does it take? And it's very manual, very time consuming. Probably the most common and the one that we see the most is the double ring. And as you can see, it's very cumbersome as well. And what they do is they bring a tank of water or a big truck, and it takes hundreds of gallons of water, and they saturate that outer ring, and then they keep that center ring at a constant head. So they're constantly pumping water into that. Again, it's very time consuming, usually 4 to 6 to 8 hours to do these tests, and pretty costly if you have to hire this out. So one is the MPD infiltrometer. It's a fully contained kit. Each test just takes 3 liters of water, so less than a gallon of water per test. And so it was established, that I mentioned, at the University of Minnesota after these 2 guys named Philip and Dunn in 1993. They figured out how to calculate KSAT, whether the ground was wet or dry. In 2007, the University of Minnesota modified that test to bring it to the ground surface. And then we started going through research and development, going through the ASTM standard committees and subcommittees. And eventually in 2018, this MPD infiltrometer was established as an ASTM standard for calculating KSAT, and then things started taking off for the MPD infiltrometer. So that is a little bit of the history of that. But like I said, now you can go out with a 5-gallon jug. You can perform 5 tests quickly and easily, and it's all automated. And so it's really simplified that process. I'm going to show a quick video for you. I thought this was already in the presentation, so I apologize. It'll take me just a second to go to our website. Let's see here, MPD. So here is the video. This is about 4 minutes, but it's a really good overview and gives you a really good idea on how the MPD works. So I'll play that and then continue after that.
Upstream Technologies' automated MPD infiltrometer follows ASTM standard D8152 and will calculate saturated hydraulic conductivity of soil, or KSAT. It is used to design, build, and test rain gardens, infiltration ponds, bioswales, septic systems, and any location where steady-state infiltration testing is required. Lightweight and compact, the MPD can go anywhere and uses less than 1 gallon of water per test. This kit utilizes a graduated cylinder and an automated test head to collect the data. The anti-scour baffle and seal prevents the soil surface from being disrupted when filling the cylinder with water. This automated tablet-controlled system removes any chance for human error. Anyone can operate this instrument with little to no training. Simply consult the in-app guide for step-by-step instructions. This system incorporates a Garmin GPS system to automatically report the exact location the test was conducted. When performing a test, the first step is to take an initial moisture reading using the supplied meter. Slowly press the probe into the ground 5 centimeters and wait 15 to 20 seconds for the gauge to settle. This gauge is in 10% increments. The result today is 30% moisture. Using the wooden set and mallet, tap the cylinder into the ground 5 centimeters. Make sure it is not loose and creates a tight seal with the soil. The anti-scour rubber seal may move during this process. Reach down and reset this seal. Press and hold the button on the top of the MPD head to turn it on, and a green bar will appear in the app. Tap this green bar and a dialog box will appear. Enter the initial moisture reading, in this case 30%, and enter a name to identify this test. Set the tablet down and fill the cylinder with water. Place the MPD head and hose in and on the cylinder. Pick up the tablet and tap the Submit and Begin Test button. The MPD app will now turn the green bar to orange to indicate the test is running. The MPD head will measure the water head drop over time and automatically record the data required to calculate hydraulic conductivity. It is best to let the cylinder drain completely before finalizing a test. This will usually take about 45 minutes to an hour, depending on soil conditions. When the cylinder has drained, remove the MPD head and cylinder and set them aside. Then take a final moisture reading in the same location as before In this case, the moisture reading is 80%. To complete the test, tap the orange bar in the app and enter the final moisture value. Then tap the button Finalize Test. All data will then transfer from the MPD head and will be stored on the tablet. We are now ready to begin another test. Ground variations change and infiltration will vary around the site. Best practice is performing multiple tests and create a site average. Ground variations include soil composition and compaction, boulders under the test, tree roots, and even mole and ant tunnels will have an effect. When testing is completed, the tests are uploaded to Upstream's cloud server, where the calculations take place. A site report may then be instantly downloaded. This report contains a description of the site, a best fit site average, a satellite photo of the site with a GPS map pin for each test performed, and the hydraulic conductivity for each individual test. To maximize time in the field, Upstream Technologies offers a triple MPD kit, so 3 tests may be run simultaneously by one person.
So that is a quick overview of the MPD infiltrometer and how it works. Oh, hang on a sec. So lots of testing. I talked about the ASTM standard and the committees and subcommittees. This was an internal tank that was used to look at this infiltration. Started with a completely dry tank, kept doing tests until there was standing water, so fully saturated, to show that you can calculate KSAT whether the ground is wet or dry. It was tested fully from 33 degrees, just about freezing, all the way up to 120 degrees. And then it was tested in a product called the Thermotron, from sea level all the way up to 15,000 feet. So it can be utilized across the country. Lots of side-by-side testing. This is a geotech that we used here locally. And we came in and we did 4 tests around his one single double ring. And we were done in about an hour. It took him 6 hours to do that one test point. So definitely lots of time saving, lots of water saving, as well as a lot less costly. Again, the ASTM standard was established in 2018. And so now you can do these tests quickly and easily and for a lot less outlay of cash, so a lot cheaper. As it talked about in the video, you can do multiple tests at the same time. Once those tests are complete, it'll go to the tablet that's included, and you can then it uploads to our server once it's connected to the internet, and then you can immediately download that report. So it talked about this a little bit in the video, but it's pretty cool. You can download this instantly. It gives you a satellite photo, gives you the GPS pinpoints of all the tests that you took, as well as the KSAT for each of those test points, and then an average for the whole site. Being utilized quite a bit across the country, up into Canada. We're even seeing activity in the Scandinavian countries, Sweden and Norway. Here in North America, we crossed over the 7,000 tests, so it's continually growing. Looking at Oklahoma, we're kind of surrounding you guys at this point, but no tests are being done. And that kind of brought up the question, originally when I was asking if you guys do this kind of testing, is wanted to see if that's, I guess, anything that you see a use for. Is it something that you just don't see these tests or require them for sizing retention ponds and things like that? Does anyone have a thought on that at all? Okay. 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 Well, that's another thing as you guys do work through that, um, keep us in mind. We certainly want to do whatever we need to do to make sure that we're listed as an option. Because again, lots of these manuals that we're seeing across the country, they'll list double ring, but they'll also list the MPD. And again, there's been lots of testing side by side to show that they're both able to achieve that KSAT. So definitely want to make sure that if there is manuals being created, that we get you whatever information you need so we can be an accepted form of measurement. So that's the MPD. They come in two different kit sizes. The single kit, just under 5,000, that comes with 50 uploads. The triple kit's just under 10. That comes with 100 uploads. These kits do not require any kind of monthly or annual service fee or anything like that. It's all on the usage and the uploads. Once those uploads are utilized, you can purchase additional uploads for as low as $20 each. So as you can see, rather than spending $800 to $1,000 for a single test point, you can do a whole test and do it for quite a bit less expensive. All the pieces and parts are under full warranty. So if anything happens to it, if something stops working, we'll fix it or replace it at no cost. So the other thing that we're starting to see is because it's digital, we're seeing cities and municipalities using this as a way to really track those retention ponds and figure out what the maintenance triggers are, what are the levels of infiltration, because you can go out and do these tests so quickly and easily. And because it's digital, they're looking at ways to tie it into their asset management software, their GIS software, things like that. So that is a quick overview of the MPD infiltrometer. If anyone would like more information, we have a group that focuses just on the MPD. So we could, I can put you in touch with them and they could give you more detailed information if there's questions. But if there is anything right now, if you any questions before I move on to the SAFL baffle at all? No? Yeah, and those are some things that we've looked into. As of right now, they're just being sold as a kit. But we do have groups that have those and can source those out. But as far as in Oklahoma, I don't believe we have any there yet. So so that's something we can keep talking about. So I'll jump into the SAFL baffle, and for those that have not heard of the SAFL baffle, it does stand for something. So SAFL is actually the St. Anthony Falls Laboratory. You can see the sign in the back there. It says SAFL Outdoor Stream Lab. This is a hydraulics lab that was built on the University of Minnesota campus back in the 1930s. So it's been there a long time. People come from all over the country to do testing here. It's really unique in that it sits right on the Mississippi River, and you can't see the water, but you can see the bridge up on top. The water runs up on top, and then it runs down below. And so there's a 50-foot drop from the top to the bottom. And so on the outside, they do lots of testing with ground cover and erosion and water movement. And then inside the lab, they run the river right through the laboratory down multiple levels. And so the river is running through the lab down that 50-foot drop, and they do lots of hydraulics and testing in there. Like I mentioned, people come from all over the country to do testing here. And what happened was, back in 2007, our Department of Transportation went to St. Anthony Falls, and they said, we're having a problem. We put in all these sump structures across the state, and they're capturing only about 30%, 35% of the sediment, because what's happening is it captures the sediment, and then if a big storm comes through, it washes all that sediment out and sends it downstream. So they asked St. Anthony Falls, can you figure out a way to stop that from happening? And so they embarked on a 4-year research and development to try to solve this problem. And after 4 years, they created the SAFL baffle. So the SAFL baffle is a very simple solution, but it took them a while to figure out all the details. But it simply goes in a standard sump structure, and it eliminates all that washout. So now you can take a standard sump, put a SAFL baffle in there, and get up to over 80% TSS removal simply by putting a SAFL baffle in there. This is some of the testing that was done. These are 2 sump structures that are exactly the same. And you can see on the left, without the SAFL baffle in there, all that sediment is getting resuspended and washed out and sent downstream. Once they came up with the solution, you put the SAFL baffle in that same sump structure, and even at higher flow rates, it eliminates all that washout, creates a flow through there, and now you can have this standard sump structure and reach those 80+% TSS removal numbers. So now you can get the same kind of capture rates as a hydrodynamic separator, but about 1/5 of the cost. So quite a bit less expensive. They started out very heavy in Minnesota. Now we're in about 27 states. We have probably 150 to 200 of these that go in the state of Minnesota every single year. But as I mentioned, it's expanding out. We're starting to see some activity in Texas and, again, kind of surrounding Oklahoma. But it's something that if you guys run into situations where you need to get sediment out of the storm drains, this is a very cost-effective way to do that. And we're gaining popularity every day. So we've been excited to see the expansion. And again, we started out primarily in Minnesota, and now we're out into 27 different states. It's focused on the sediment side, so it definitely falls in the hydrodynamic separator category. Turbidity is more of the real fine stuff, and we run into that a lot in Georgia because they have real fine clays. And so we focus on the sediment, which is 70 microns and above. So when you look at these 2 areas, we fall into the sediment, which is 70 microns and above. Anything smaller than that would require some sort of filter or membrane type system, because the hydrodynamic separators only handle 70 microns and above as well. And when you look at those, they're typically $20,000 to $30,000 to $40,000. The average SAFL baffle is about $4,500. So quite a bit less expensive. The other thing that we're seeing, and again, this is just ideas to keep in mind, if you do need to capture the real fine particle sizes and get rid of or do the turbidity, we've been seeing a lot of pre-treatment with the SAFL baffle. So the SAFL baffle can be used as primary treatment and achieve those 80+% TSS removal numbers. But if you have some sort of filter system or a pond or an underground chamber, the SAFL baffle can be utilized as a pre-treatment device and part of like a treatment train. That's very common. We're seeing that a lot. Again, about 90 to 95% of the sediment is 70 microns and above. So that's where our focus is. And we really help with the TSS removal goals. That 80% seems to be very common, and we're achieving those all the time, 80+% TSS removal. It's also helping with reduction of dredging costs because now we're vacuuming that upstream, and also phosphorus removal. So St. Anthony Falls is doing a lot of work with phosphorus removal testing. It's years in the making, and they're looking at phosphorus. Is it all in the water? Is it clinging to the sediment? And there was a test done in Florida where they showed about 50% of the phosphorus is clinging to the sediment. So if we can get the sediment out of there, we're really helping with that as well. TSS, again, two parts of that. There's the capture piece, but also the retention. And by adding a SAFL baffle to a sump structure, you not only get the capture, but you retain it and achieve those high TSS numbers. It's built out of stainless steel, so built for longevity, and there's no maintenance to it. So there's no moving parts or maintenance. It's a very simple solution. Once it's installed, the only maintenance is vacuuming out those sump structures. The other thing that was a big concern for the DOT, now that we're putting something into these sump structures, they wanted to make sure that it wasn't going to clog or back up systems. So there was lots of testing and research into the fact that we want to make this so it's not going to clog. But if for some reason something happened and I don't know, something came down and it clogged it, it's not going to back up the systems. So lots of testing with that. If you haven't seen the SAFL baffle, this is what it looks like. Again, it is built so that it could be retrofit without having to tear up the streets. So it can be new construction, but it comes in panels and parts so that everything fits through the manhole and can be retrofit as well. So being utilized quite a bit in both of those scenarios. A lot of times it's new construction. Other times it's being retrofit into existing structures. And the cities or municipalities don't need to tear up the streets. They can just put these in. The testing that they did, that 4-year process, lots of testing, case studies, real life performance results. But the other thing that was done during those 4 years was they worked with Bar Engineering and they created a software called Shazam. And I don't know if anyone's heard of Shazam, speak up if you have, but it's sizing hydrodynamic separators in manholes. One of the things that we're offering is if you have any projects that have sediment capture needs, we'll do this free analysis for you, and we'll show you what the TSS removal numbers would be and the costs and the sizing for your project specifically and that location. We can also help with, do you need multiple structures? What do we need to achieve that 80+% TSS removal number? If that's something that you guys need, we can do that analysis for you. The other thing that the university looked in was the testing. So what kind of testing is going on? New Jersey testing back in 2007 was really the only test method out there. And what they would do is they take a cup of the water before the BMP, then take a cup of the water after the BMP, and then compare those, figure out what these BMPs are capturing. Because they were creating this software, they needed real specific data. So they got a new test method that they created called the mass balance method. And what they did is they took 100 pounds of sediment and they would run it through all the different BMPs. They tested like 9 different BMPs, including a standard sump structure and a sump structure with a SAFL baffle, and then a bunch of different hydrodynamic separators. And they'd run 100 pounds of sediment through each of these different BMPs, and then they would drain it and figure out exactly what was captured by each of the different BMPs. And then they would run it through a sieve or a sifting system and get down to the specific percentage of each particle size that each of the different BMPs was capturing and get real specific. So this is what's been put into that software. So now you can compare these BMPs head to head. The cool thing is the University of Minnesota created this new test method. It became an ASTM standard for testing, and now the New Jersey cup method has kind of been pushed aside, and the New Jersey test method now is this mass balance method. The SAFL baffle has been tested by New Jersey or the NJCAT, NJDEP, and it's been fully tested and verified and certified by NJCAT. So that's something that has been happening. They did also lots of testing with that SAFL baffle to solve this problem. And they looked at different things. They looked at low flow rates, high flow rates, different sump sizes. And one of the things that they found with the sumps is that the deeper the sump, the more capture, which seems to make sense up into a certain point. But going the other way, they found that if they're under 3 feet, even with a SAFL baffle in there, they're getting some washout. And so we have a minimum of a 3-foot sump for both the SAFL baffle and the skunk. They both sit a foot below the outlet pipe. So that allows 2 feet at a minimum of capture space, and it eliminates all that washout. They also looked at the placement of the baffle, and if they got too close to the inlet pipe, they were getting washout. So we focus more towards the center of the structure and just make sure that there's enough room for that vac truck to get down the middle if the manhole is in the middle. We've also seen 2 manholes put in on the side if it's new construction or if it's something you can add so that the vac truck can go on either side. They also looked at different angles because, as you guys know, they're not all 180 degrees apart from each other. So depending on how the angles come in, depends on how the SAFL baffle will fit. And we can do the CAD drawings for that as well and show you how the SAFL baffle would fit and how it needs to be installed for your specific project. It also works with multiple inlet pipes. So if there's multiple inlet pipes, we can help with that and do the CAD drawings for that as well. But there is kind of one type of sump that it doesn't work very well. So something to be aware of. If all the water is coming from the top, so if it's like a catch basin at the end of a parking lot or something like that, we need at least 75% of the flow to be horizontal. So we can have some water coming from the top, but if all the water is coming from the top, we'd want to be downstream from that so we can have that horizontal flow. I talked about the garbage. This is some testing they did. They actually clogged it and made sure that even if it's clogged, it's not going to back up the system. And we have over 2,200 of these now around the country, and none of them have caused a backup. This one is in our capital city of St. Paul, Minnesota. And as you can see, a lot of garbage is coming through that. And so typically these sump structures are required to be cleaned out about every 6 months or so. That's about the typical time frame. This one is cleaned out a little bit more frequently. The maintenance crew keeps an eye on it because of all the garbage coming through. But typically they're about every 6 months or so as far as a clean out. The Shazam software, real quick. These are the 9 products that were tested. So you can compare these products head to head. And this is what we'll use, this third-party software, to do that free analysis for you if you have any projects. And what we'll do is we'll look at the acreage of the project, the impervious area, the slopes and pipe diameters and all that. And then we'll be able to give you the exact TSS removal numbers for that project using the Saffle Baffle. This is one that we did in Madison, Wisconsin. They had to hit 80%. So for this permit, they needed to be at 80% TSS removal. So they looked at, with the software, they said, well, what if we just put a 4-foot sump in there? And it came in about 32%. They put a Saffle Baffle with the 4-foot sump, and it bumped all the way up to 71%, but they needed to be at 80%. So they said, well, we could put a second structure in there, or what if we just make this structure a little bit bigger, make it a 6-foot sump. They were able to hit the 80% with a 6-foot sump and a Saffle Baffle. They also tested the Storm Scepter, the Downstream Defender, the CDS unit, and those also hit the 80%. In fact, they were a little bit higher than us, but they were also 3, 4, or 5 times the cost. So as you can see, even with one structure, there's lots of money to be saved by doing a Saffle Baffle and a sump structure. But if there's multiple structures, this can really start to add up and save the municipality or city or client, if it's a developer or something like that, can save a ton of money on that project. Again, made in the USA, 100% stainless steel. And one of the things that we did in 2019 is we always said, oh, it'll be a 20+ year lasting product. So you can put it into the sump structure and just, twice a year vacuum it out and you'll be good to go. But in 2019, we actually put together a 20-year guarantee. And so the Saffle Baffle is guaranteed for 20 years. If anything happens to it, we'll fix it or replace it at no cost. And so every Saffle Baffle comes with a month and a year stamp on it, and it's under full warranty for 20 years from that date. The DOT here in Minnesota put out a report in 2017, and they said that the Saffle Baffle is saving the state quite a bit of money. And over the next 10 years, they said it'll save the state over $26 million. Those savings come from all sorts of different things, including the reduced need to dredge. So they're not going to have to dredge as often, but also they can save money on the projects themselves by not having to put in the much more expensive hydrodynamic separators. And then they're able to also retrofit these into existing sump structures, so they didn't have to do all the street tear up and reconstruction. So lots of money was saved by using the Saffle Baffle. We were pretty excited for them to call that out. So I mentioned pre-treatment before a filter system. Here's an example of a 4-bay replacement. So a lot of times in these ponds, there's a 4-bay they put before to capture the sediment and the garbage before it goes into the retention pond. But what we're seeing is, especially if there's space restraints, rather than doing a 4-bay, putting a sump structure in there with a Saffle Baffle, if there's sediment issues, And then if there's garbage, put a skunk in there as well, and do a pre-treatment before the retention pond without a need to have a forebay where the garbage is floating in there, or they have to dredge out that forebay. We're also seeing it a lot in front of these underground chambers. So this was one that we did in Minneapolis at the 3M parking lot. They put in a big underground chamber. And so what they did was they did 3 sump structures before the underground chamber with saffle baffles in those to stop the sediment before it went underground. So we're seeing that quite a bit as well. Some retrofit things that we've seen, just again, this is more just to be aware of. If you run into certain situations where you're thinking, oh, if we had a retrofit product or something we could do without having to tear up the streets, that would be great. We had one, the one on top was a downstream defender in Utah, excuse me, and they put a big 10-foot downstream defender in this project, and they sealed the streets. They got everything opened up, and there was rocks that were coming through that storm drain. And within about 3 weeks, all that yellow plastic got chewed up by the rocks coming through there, and it stopped working. And so they needed a solution, and they didn't want to tear up the streets again. And so we retrofit a saffle baffle across that 10-foot structure. We added additional bracing so that because the flow rates were so high. But here we are 3+ years later, and it's still working great. It's handling the high flows, but also handling those rocks coming through there. The one on the bottom was a similar thing where they put in a hydrodynamic separator, the Storm Scepter in Colorado, and there was high flow rates. And one of the things with the hydrodynamic separators is they can handle only real low flow rates. So if it gets over, say, 10 cubic feet, or some are even 8 cubic feet per second, it goes through a bypass system. And so what was happening with this one in Colorado is their flow rates were really high, and everything was going through the bypass. Nothing was going through the system. Nothing was getting captured. And so they called us and they said, can we retrofit a saffle baffle in this structure? And so they used a Sawzall and they cut that inside out of that Storm Scepter. And we retrofit a saffle baffle in there, and they started catching everything. And it worked so well, they did that to 2 more Storm Scepters that summer. And then the following summer, they had a new construction project, and they just did standard sump structures with saffle baffles in them and saved a ton of money doing that. So it can handle the real high flow rates, and there's no bypass required. Some things that we've seen out there, I don't know if you'll see this product, but it's something to be aware of. It popped into Minnesota as an equal baffle about 2 years after the saffle baffle was introduced. But as you can see, it's a little bit different. It goes over the inlet pipe, and then because it's so close to the inlet pipe, they were getting washout, so they put a piece over the outlet pipe. It's also made of plastic instead of stainless steel. And so we were seeing a big confusion in the market that all these baffles were the same. And so we'd see projects with this product listed and then a picture of the saffle baffle, or vice versa. It'd say saffle baffle and then it'd be a picture of this. So just want you to be aware of that. Not all baffles are created equal. This one, actually, the problem started happening. If any pipes were sticking out at all, these were getting installed right up against the pipe. And you can only imagine the backup and the clogging and the issues that this started to cause. So that's why I don't know if you'll see it in Oklahoma, because a lot of cities are calling and saying, hey, these are clogging. We had maintenance crews that had to cut these out, and so now there's nothing in there. Can we put a saffle baffle in there? We had the worst one was, you know, there's a piece over the inlet pipe and then a piece over the outlet pipe. We had one city that the outlet pipe got pushed up against the outlet and flooded the whole street. It was like 2.5 feet of water, flooded basements, cars that were flooded. So big issues with these for clogging, and that's one of the nice things about the saffle baffle. The way it's situated in the middle of the structure, it's not causing backups or clogging like that. The other thing that we've seen is contractors just say, it's just a piece of metal with holes in it, so I'm just going to take a piece of metal and cut holes in it. Something for you to be aware of, because the problem with this was the contractor charged them for a saffle baffle, and then they just built one. And this was only 25% open space. And it was actually causing more of a turbulence than if it wasn't even in there. So that 4 years of research really did create the saffle baffle to be something unique, something that really works and is effective. And it was this magic number of 48% open space that created that flow through there and eliminated all that washout. So that is a long-winded explanation of the saffle baffle. It was, created to stop that sediment so we can achieve those high TSS numbers. We can handle real high flow rates, and it's built for long life and guaranteed for 20 years. So that is the saffle baffle. I just have a few more slides on the skunk, but before I jump into those, does anyone have any questions or thoughts on the saffle baffle at all? Yeah, well, so typically they go in a standard sump structure, but that structure could be round, it could be square, so it could be that. If it's a cement structure, it just gets drilled into the cement structure, and it's a very easy to install and can be retrofit. If that structure is plastic or a different material where we need to secure it, then that's more of a new construction type structure. And so it would be kind of project by project, but that's something that we can help you with and do that analysis for you, number one, but also help you with the structures and make sure that those are the right types of structures, especially if it's a new construction type project. Yep. I don't see any other questions on the chat. Let's see here. Anybody else? You're making it easy for me. Sorry I talked so long there. All right, so I just have a few more slides, and this is just to let you know about the skunk. It's our newest product. We're excited about it because it really gives you another option. There's some other garbage capture devices out there. Does anybody have a garbage capture product that they've used in the past, or is this anything that you guys run into or utilize at all? Okay. All right. Well, there is some other ones out there, but typically they're a single piece. And so we had the reason that this product came about was we had a project in Maryland that they had a saffle baffle with another product, and they were, going to use them both in the same structure, which is fine. The SAFL baffle and the skunk can be in separate structures, or they can be in the same structure, and we can help with that decision as well, and kind of looking at different placements of that. But this particular one, they were both going into the same structure. The contractor sealed the streets and they weren't put in. And so they called us kind of in a panic because they were going to be able to retrofit the SAFL baffle in there, but this garbage protection unit was one piece and it wouldn't fit through the manhole. So they called us and they said, do you have a product that comes in panels like the SAFL baffle for garbage capture? And at the time we didn't have it, but we thought that's a pretty good idea, and that would go right along with our SAFL baffle for the retrofit or new construction thing. So we embarked on a 2.5 year research and development of the skunk. It originally was called the Garbage Guard, and it was all black. But as you can see, it goes over the outlet pipe. It also sticks a foot below the outlet pipe, so the clean water can come underneath. And then all the floatable debris and garbage can be captured. When we had our first installation, this was a few years ago, it was at a Top Golf up here. You guys have Top Golf down there at all? Have you heard of that? Okay, so we had a Top Golf and they put in a garbage guard, and we actually called the product the Garbage Guard, and it was all black. And the contractor, that middle piece is a little bit different. And so after figuring it out, he said, my only issue was it was hard to know which piece went where. You should make that middle piece a different color. So we changed it from black to white. And once we put it together, we thought we should call it the skunk instead. So we changed the name to the skunk. But here is what it looks like. And it comes in four different sizes, depending on the outlet pipe. But it's built in panels that all fit through the manhole. So it can be new construction or retrofit as well, just like the SAFL baffle. So that's the skunk, also made in the USA. And so that is what we are doing here at Upstream. And we have the MPD infiltrometer for the geotech side. More on the civil side, we have the SAFL baffle for sediment capture and the skunk for floating debris. Any parting questions or thoughts at all? All right, thanks, Jordan. Yeah. That would be great. Yeah, that's kind of what my one question to you guys here is, if you have any products or any projects coming up that have sediment capture right now, is there anything out there at all? We could do that free analysis for you. Okay, great. Well, I really appreciate your time and just taking time out of your day to find out about Upstream Technologies. We're excited to work with you guys in the future, and would love the opportunity to do that free analysis and at least show you how the SAFL baffle would perform, and it's specific to your project. So this is my email. If you have any questions or have a project you want to send that we could do that analysis for, we do first initial, last name. So I get blessed with Bleach. So it's Bleach at Upstream Technologies, and then we're .us. So that's my email, and then that's my direct number if you have any questions or thoughts. I would love to talk to and work with you guys in the future, that's for sure. Thank you. Thanks, everybody. Have a great rest of your week and weekend, and look forward to hearing from you. And then, Rebecca, if you want to get a list of the people that would like PDH certificates, I can get those put together, and if you have their emails, I can send it to them as well. Yeah. Sounds great. Thank you very much. Yeah, have a great day.